Hello, this is Roman Playtech. I will be covering exploring the effects of war and rebellion on the value of the currency, the Rhenish Guilder, in the 15th and 16th centuries with Bayesian linear regression. This report will include a description and context of the data, visualization of the data, and a model diagram with prior parameters. Data will be explored based on data that was sourced from the medieval and early modern databank, which has the exchange dataset from METS. That dataset for the exchange rate has values of currencies from 30 cities from the 1300s to the 1800s. The Rhenish Guilder, which is one of the ones we'll be talking about, or Gold Guilder, is recorded in the dataset with annual value data from 6 cities from the years 1400s to the 1700s, so the 15th and 16th centuries. And in those centuries, the Rhine was governed by many small independent states, but they were partly controlled by the Holy Roman Empire. The HRE, or the Emperor, was often at war for various reasons during the 15th and 16th centuries. The HRE also had to frequently quell peasant uprisings. So my hypothesis is that a linear regression prediction of the value of the Gold Guilder can be predicted based on the year and if the HRE was at war. So here we can see some visual context. We can see in the middle the cities that the dataset covers that talk about the Golden Guilder. And in the middle you can see Cologne, which is the one we'll be focused on. That has a lot of observations over the 2 centuries. On the right you can see a list of wars that occurred, and we'll be using that as a binary if the HRE was at war or they weren't. And then on the left you can see where the Rhine region is in modern day Germany. So here are some data visualizations. First, I'll talk about the changes of the values. I found that you could get this nice looking gamma or maybe inverse gamma distribution if you applied a log and absolute value transformation to the difference between years. And that was similar in many of the different locations. But here, for instance, you can see it in Cologne's example. Then next to it, you can see that there is a like a linear plot that shows how the value changed across the 2 centuries and 2 or 3 centuries, and you can see how the orange is when war was happening. And it seems that there's a lot more volatility during those periods, but that might be a bit of a weak suggestion. Still, it's interesting to test. And then on the bottom you can see that likely most of the changes were null or there was a negative change, and only some of the times it was a positive change. But then you can also see that the value change for positive was very strong, while the value change for negative was small on that log absolute transformation. So that suggests that when it increased, it went up 1 or 100 values, but when it went down, it only went down 1 or 10 values in terms of magnitude. And then on the far right corner you can see how that log value, that log ABS value transformation of change depending on when war was happening and when war was not happening. And you can see that there's a bit of a shift in the green one, and that suggests that war makes there be more changes. And that makes sense given that in war you pay a lot more mercenaries, and so there's a lot more of your currency flowing within the economy, creating fluctuations. So here we have the Bayesian linear regression diagram. at the top we had a formula for all locations with a different y and year relationship for different locations, but in this diagram we're looking mainly at Cologne. You can see that most of the values are generally, most of the distributions for the different parameters of beta are set to be relatively uninformative. B2, for instance, is not so uninformative because I want to make it just a positive or a negative or a 0 value. B4 is a reasonably informative value because I want to shift B3. I want to be able to change as B3's output to be maybe shifted to the left or the right to be positive or negative. And then the inverse gamma distribution I have set for B3, and that's to reflect our observations in the data based on the changes across from the past year and the current year once you've applied a transformation to it. And so that way we can see how the value of Cologne changes based on if war is happening and based on what the year is. And then finally we have the errors based to be set to a gamma distribution, because I think that's the common way to do things in that sense, and it seems flexible. And these decisions were based on the correlations between value and different things in the data. So there's a strong correlation between year and value. There's a strong correlation, there's a small correlation but a recognizable correlation between war and value. Thank you.